When Brendan asked me to do this, I said, well, do I need to prepare anything? No, he said, just think about the talk as you're going along and make some observations. So my observations really not about flying foxes at all, but they're very much more about climate change and some of the things that I think are important. And I've got half a dozen points that I thought would be useful to make. One is the observation that Justin made was about the fact that the temperature extremes in places like Melbourne are much greater than they are in the tropics. And as a tropical biologist, this is something that has concerned a lot of us for a while, that we think that a lot of tropical biology is going to be much more vulnerable to climate change than a lot of the temperate stuff. And you think, well, why should it? They're used to warm temperatures after all. But that is something that we've recognised, and it is a big concern. And one of my colleagues from the Smithsonian, Joe Wright, plotted a map where he showed just how far species have to go in parts of the tropics if they have to avoid some of these higher temperatures. So you look at places like the Amazon, and these things, species are going to have to move very large distances if they want to find habitats that are going to be cooler as temperatures rise. Now, we know from studies of past ice ages from Europe, how species that were found in Norway, the northern parts of Norway, actually moved all the way down to the Mediterranean, and then moved back up again with the ice sheets and so on. So some organisms really do have an ability to move quite a lot. We also know that there are a lot of plant genera that actually never made it across the Alps. They were lost. Those species, those genera were lost. So some things can move, others can't. So that's a general thing that we have to be concerned about. Another thing that people are observing is that because as things are getting warmer, the timing of interactions between organisms is changing as well. One of the examples that I don't know very much about it, but I've certainly heard people talk about it, is the mountain pygmy possums in southern parts, in the higher landscapes further south. They're very reliant on these bogong moths, which fly up and roost in very large numbers up in the mountains, Kosciuszko and places like that. Now, what's happening is temperatures are getting warmer in the mountains, the mountain pygmy possums are coming out earlier, and the moths haven't arrived. So there's this disconnect, and there's a lot of instances like that. So these things tie up with some of the stuff that Justin's talking about. It's very complex. Third thing that I wanted to observe is that a number of people say, well, look, I actually write about extinction and extinction rates. So one of the things that people say to me is, well, surely, what about evolution? Aren't species evolving to cope with all of these things, new species and so on? Now, a guy called Ari Hoffman, who's a professor down at University of Melbourne, did some experiments with Drosophila, the fruit flies, everybody's experimental organism. And what he did was he took some species that were only found in very localized habitats, but very endemic things in the wet tropics, and he took some more widespread species, and he found that the more endemic species had very little ability to adapt to desiccation and a drier environment. He put through some experiments to see how well they adapted. The more general things, Drosophila melanogaster, which is the common fruit fly, boy, that could adapt to anything. So, no, I don't think evolution is going to work very well. We're not going to get new species to adapt to those things. So, where am I with this? That's evolution. Right, so, okay. So one of the things that when I asked students about a lecture about extinction, I said, how many species have gone extinct since the year 1600? And I get the students to put their hands up, 500, 10,000, 1 million species, In practice, since the year 1600, about 1,100 or 1,200 species are recorded of everything as having gone extinct. Okay, extinction rates, global extinction rates, are much lower than people think. And one of the reasons I think this is because an extinction of a species occurs when all the individuals of that species that are there all go at the same time. Now, big warm events like this You know, if they occur across a larger landscape, you can wipe out whole species if they're restricted in it. So I actually say extinction rates are much lower than people think, but they are going to accelerate enormously because of climate change. Climate change is a global phenomenon. So we can expect to see large-scale global events which will eventually wipe out species. And they'll also interact with all these other threats like land clearing and pollution and so on. And we're already seeing people publishing papers showing all those interactions between them. Climate change is interacting with all of these things. So it's a really big concern. Finally, I moved to Australia in '95 from the UK to head up a research centre on tropical forests based up in Cairns. It was a wonderful experience to move up there. And this was one of these cooperative research centres. So we had one for the rainforest, there was another one for the reef, coastal and so on. And we were basically a group of university researchers, CSIRO, and then a whole range of partners who were the users of that information. And we had some research programs on a range of different things. We were first of all trying to find out what organisms were there, impacts of roads and tourism and all those kinds of things too. And Carla was one of my program leaders looking at landscape restoration, for example. And then some of the staff came to me and said, we've got to do something and research about climate change. So I went to my board of directors, a board of 12 directors, and I said to them, research is showing us we've got to start looking at the impacts of climate change on tropical forests. And one of the senior board members, who was actually a very senior land manager for one of the government facilities, said, well, why should we do research on it? We can't do anything about it. Right. So this is a problem that we have to face now. Is we have senior people in positions like that, or government, or people in government who have to make decisions about these things, and they're complex issues. They're much more used to dealing with simple issues. You notice that the government's saying it's going to put $20 billion into a fund for medical research. That's great. They understand. People have got cancer, they want to cure it. Okay. But more complex issues are difficult. Now, a couple of years ago, I saw that Brendan Mackey, our beloved leader here, and some of his colleagues were successful in getting an ARC grant to look at body size and climate change. A few days later, I read in one of the newspapers, it was ridiculing why the government, Australian Research Council, had given them a grant to look at something as silly as that. Okay. But the reality is, larger organisms are going to be more affected by climate change. Larger organisms are the things that are going extinct, generally speaking. It's the big things that are going extinct, and the smaller things tend to be more resistant. And I remember in 1975, I was doing my PhD, and one of my friends, I'm an entomologist, one of my friends was looking at insects. He was rearing all these insects. 1975 was an exceptionally hot summer in the UK. When he reared his insects and he was describing them, they were half the size that they would normally have been in other years. Now you think about it, they also went through their life cycle in double the time. So if you're working on pest insects, climate change, boy, those things can multiply in very large numbers. So we need to be looking at these things, and we need to think very broadly about them. Thank you.